Hello, sixth graders, and welcome to week 8 of social distancing school. This is Mr. Shear, and we are in the penultimate week of school as far as work goes. And if you don't know, penultimate means second to last. So we've got this week of school with work, and then you've got next week of school with work, and then the final week of school, no new work. So welcome to June. All right, we were doing measures of variation this week. I'm going to start us off with 4 vocab terms, and I'm going to add a 5th vocab term at the end. This slide is a lot of information. We're going to go through it individually. I'm going to point out one, this very first definition, which is the word quartiles. And that's just the concept of dividing a data set into 4 equal parts. Really, that's a conceptual vocabulary term. You don't have to do that or find that on your work this week. What you do have to be able to find are the first and third quartiles, the interquartile range, or the IQR, and the range. And I'm going to show you how to do each of those. So we really don't need the word quartiles. Okay, we're going to look at a data set to start. Here is a big data set, lots of numbers, in order from least to greatest. First off, we're going to find the median. So you always want to start your assignments this week by finding the median. If you don't remember, the median is the middle of a set of numbers when they're in order from least to greatest. You'll notice there's 2 numbers in the middle because it's an even data set, 3 and 4. So the median would be you splitting the difference and coming up with 3.5. It's a halfway point. What I want you to notice is if the halfway point is here, there is a series of numbers less than that and a series of numbers greater than that. So what the quartiles are is the first quartile, again your median was here, Q1 is the middle of all the numbers smaller than the median. So that's the median of everything less than the median. And that's labeled as Q1, quartile 1. In this case, it would be in between 1 and 2, so 1.5. Q3, or the third quartile, is the middle of all the numbers greater than the median. So here's all the numbers bigger than the median, and Q3 would be right in between 6 and 7, so 6.5, we would call that Q3, or the third quartile. Here's another example with less numbers in the data set. Maybe that'll make it a little easier to see. You've got 6 numbers in this data set, so the 2 in the middle are 25 and 30. So your median would be 27.5. 3 numbers to the left, 3 numbers to the right. Q1 would be 8, because that's the middle of all the numbers smaller than 27.5. And Q3 would be 50, because that's the middle of all the numbers greater than 27.5. Again, that's you finding the first and third quartiles of a data set. So we went over the first and third quartiles. We're going to go to the next vocab term, which is the interquartile range, often abbreviated as IQR. And what this is this is the distance between the first and third quartiles of the data set. It's Q3 minus Q1. Here's that number set we just looked at, and Q3, quartile 3 was 50, quartile 1 was 8, so the IQR, the range, is just 50 minus 8, 42, and you would just label it as IQR is 42. Okay, so we've gone over first and third quartiles and interquartile range. Now we're going to look at range. And range is pretty straightforward. It's just the difference between the greatest and the least values in the data set. So here's that original data set. Find the biggest number, find the smallest number. Biggest number is 8, smallest number is 0. To find the range, you just go 8 minus 0 equals 8. The range is 8. Again, it's just the biggest number in a data set, subtract the smallest number in a data set. Okay, so here's one example for you to try. you're trying to find the median, Q1, Q3, and the IQR as well as range for this data set. If you said the median was 60.5, you're right. There's two numbers in the middle because it's an even data set. So 60 and 61 were in the middle. And the halfway point of that would be 60.5, 60.5. So the median's 60.5. Now to find Q1, you want the middle of all the numbers smaller. So hopefully you're saying 58. And to find quartile 3 or Q3, you want all the numbers greater. The middle of all the numbers greater than 60.5. Hopefully you said 64. Next, you want to find the IQR. So again, it's Q3 minus Q1. 64 minus 58 is 6. And last, you want to find the range, which is 71 minus 56, biggest number minus smallest number. The range is 15. Cool. Last vocab term is outliers. And really there's two definitions I like to think of. One is simple and one is difficult. We're going to start with the easy, simple definition. And if we have time or at the end, I'm going to stop the video. Let me say this differently. At the very end of this video, I'm going to give you a chance to turn it off if you're watching. And then I'm going to go back and give you an example of the difficult technical definition of an outlier. But for the sake of simplicity, what an outlier is it's a number in a data set that is way out of normal compared to the rest of the numbers. So if we look at this data set, you got 2, 212, 214, 218, and if I asked you if there's an outlier, the answer would be yes. And hopefully you're saying it's 2. It's a number way smaller than the rest of the numbers in the data set. Here's the technical definition. We're going to come back to it at the very end of the video for those who want to stick around and get the technical definition of an outlier. Okay, so to recap, measures of variation. Median is the middle of a data set. You always start by finding that, and you put the numbers in order from least to greatest, and you find the middle. Quartiles is the concept of breaking your data set into 4 quarters. Q1, the first quartile, and Q3, the third quartile. That's where you find the middle of all the numbers smaller than the median. That's Q1. And you find the middle of all the numbers larger than the median. That's Q3. The interquartile range, IQR, is the difference between Q3 and Q1, so you just subtract Q3 minus Q1. And the range is the difference between the biggest and the smallest number in a data set. It's big minus small. Lastly, outliers. And again, the simple definition is it's a number that's really different, way bigger or smaller than the rest of the numbers in a data set. So you got 2 assignments this week. They're both worksheets hosted in Google Classroom. There's no Alex or book assignments this week. Note, there are no answer keys for the assignments this week. You should be able to type on the worksheets. So I tried to make it user-friendly this week where you could just type your answers on the worksheets and submit those back to the Google Classroom. That's all. You can go ahead and stop the video now, or you can stick around if you want to get a geek out with me and hear a technical definition of an outlier. I'm going to go back to those previous slides. So I hope you guys have a great week if you go ahead and turn the video off now. And for those who want to stick around, we're going to go look at the technical definition of an outlier. So as this says, an outlier is a data value that is way bigger or way smaller than the other values in a data set. It's the second sentence here that's really important. If a data value is more than 1.5 times the value of the interquartile range beyond the quartiles, it is an outlier. So again, if the data value is more than 1.5 times the value of the interquartile range beyond the quartiles, it is an outlier. What does that mean? So we're going to look at a data set. These are the ages of candidates in an election, 23 years old up to 72 years old, and they want you to find any outliers in the data. So first we'd find the median, which in this case is 55. And then you'd want to find Q1 and Q3. Q1 would be 48. Q3 would be 63. The interquartile range would be Q3 minus Q1, 15. So we found the IQR of 15. Now going back to that definition, an outlier is when a data value is more than 1.5 times the value of the interquartile range. So let's find 1.5 times the value of this interquartile range. 15 times 1.5 is 22.5. Now, if you go back, it says 1.5 times the value of the interquartile range beyond the quartiles. So we just found this 22.5, and now we're going to subtract it from Q1 and add it to Q3 for two different numbers. What this tells us is, are there any numbers of candidates, any of these candidates' ages that are outside of this range and outside of this range? Well, yeah, this 23-year-old. He is more than 1.5 times away from the IQR times 1.5 minus Q1. He's too young, so he would be an outlier. Is there any candidates older than 85.5? No. So there's no ranges that are too big. So the only outlier in this case would be 23. Probably sounds way more confusing than it is. Thanks for sticking around if you watched this part. I hope you guys have a great week, and I will talk to you soon.